Hello and welcome to the next video. In this one, we will talk about the different addressing modes, building up on what we covered in the previous video with the basics of load and store instructions. So there are so many different variations to load and store in ARM assembly language. I will write a few here and then we'll try to cover as many as we can. There's probably 7 different modes, or actually like 11 different modes. One of them is the register immediate, and the other one is the immediate offset. And there is register offset, scaled register offset, and so on. We'll start with one at a time, and we'll do an example, and then we'll take it from there. So first, let's do a couple of variables here. I'm going to initiate a variable. I'm going to make a pointer that points to that memory location, and then we'll do load and store. Okay, here I made a variable called alphabet, and I stored the alphabet in it in lowercase, and then I allocated some space using the skip directive in a different location. And first I'm gonna make a pointer that's pointing to the alphabet. So we're going to load R0 with the address of alphabet. And after that, actually, let me take this out of here. This is my pointer. And I'm going to do register immediate. And you guys have seen this already, so you can load a word from that location into, let's say, R1. So this is going to take a word and it's going to load it into R1. You can add an offset to that and say, for instance, load into R2, wherever R0 is pointing to, plus some number. So for example, plus a value of 4. So this is going to actually increment by 4 and then load a word from there. You can also do register offset, and you can specify, instead of declaring an immediate value here, you can declare that offset using another register. So that value, let's say, will be offsetted by, let's use R, let's use R, I don't know, R5 in this case, or R4. So this is going to take the value from R4, and that will be the offset value. So I have to have something in R4 before that. So I'm going to just move a value into that register. Let's do 8. And there is one more here. And we'll do the scaled register offset. And basically, the number in this register will be scaled before we can move to it. So I can do also an LDR, and let's do R5, already use R4. From this pointer, offset it by the content of register R4 and offset it by some multiplication. Shift left by 1. I'll explain those in a second. All these are addressing modes actually for load instructions. And there's still more. There's still more that has to do with post and pre-index, but we'll talk about that in a minute. Let me go quickly through these here. We have first set a pointer that's going to point to this alphabet, and I expect it to start at some address, for example, like 100000. And then it's going to be pointing to the address of the first variable. In this case, it's a lowercase a. And when I do an LDR from that location into R1, I'm going to grab a word from that location. So a word is 4 bytes, which means it's 4 characters. So I'm going to load ABCD into R1, or the hex values of ABCD into R1. And then in the next example, I'm going to load a word, but that word is not going to start from the beginning. It's going to be offsetted by the value of 4. And I have specified that value right here. An immediate value, like a raw immediate value in my instruction. In the next one, I'm doing something similar, but instead of declaring that value using an actual number, I'm telling the assembler, hey, the value you need to offset the pointer by is actually specified by another register, or basically my value is stored in R4 in this case. So add whatever that value is to the base address and then grab a word from there and store it into the LDR instruction. Sorry, store it into R3. And then the last one is I'm doing an offset, but I'm using the base address, which is R4, and then I'm adding the content of R4 multiplied by this amount. So R4 in this case contains 8. If I shift 8 left by 1, I'm multiplying by 2, so I'm offsetting the base address by 16, and I'm going to grab a word from that address and then grab and put it into R5. So just a quick reminder, when you shift left in binary, you're essentially doing a multiplication. So here's an example. If I have the value 0010, now if I shift this value left by 1 bit, what do I end up with? I end up with 0100, assuming I only have 4 bits. So obviously this was 2, and then if I shift it left by 1, this became 4. So essentially every time I shift left, I multiply by 2. So when I had 4, or when I had 8 here, and then I'm logically shifting it left, basically multiplying that 8 by 2, and it becomes 16. So I'm adding 16 to the base address that is stored in R4, R0, and then I'm going to load a value from there. So let's compile and load this to the board and see how this works. And looks like I got an error. Line 2. Oh, this is supposed to be. Okay. Okay, my code has been downloaded to the board. Let me step through the first instruction actually. So I have set my pointer to point to the alphabet ASCII string, and as I expected, that starts at address 100000. I can go there and look at it. So this is my alphabet, 61, 62, 63, 64, etc. And then I have skipped a certain amount of locations. Maybe when we use the store, I can start storing the values back into this location. Now let's step through it, either this one or this one. So now I'm going to load, let's do this one. I'm going to load a word from that location, put it into R1. So R1 now contains 61, 62, 63, and 64, which are the hex values of A, B, C, D. Now the next instruction is going to load a word as well from that address plus 4, right? So if I step through it, you will see that the value of that's stored in R2 now is 65, 66, 67, and 68. So essentially, I'm going to that location and I'm incrementing the base address, which was originally pointing to this 61. It was pointing to this location. I incremented that by 4. So obviously plus 4, I'm getting to this location, which is storing the value of 65. And I'm loading a word starting at that location. So I'm loading 65, 66, 67, and 68. That's what I got in my R2. And then in the next instruction, I am going to increment the base address by 8, and 8 is specified in this register R4. So if I go up by 8 from the base address, this was the base address. The base address is right here, and it's storing 61, which is the hex value of lowercase a. If you add 8, you end up with this address, which is 69, or which stores the value of 69, starting of 69. I'm loading this word now from memory into R3. And then the last one here, I'm going to offset the base address by this value. How much is this value? It is simply 8 multiplied by 2. 8 times 2 is 16. So if I execute it, I'm going to get this value right here. And if I go back to memory, this was my base address. This is the base address plus 16, right? So this is, we just did the base address, the base plus 4, the base plus 8. This is the base address plus 12, and this is the base plus 16. And a quick shorthand to count as well. If this is the address, going up by 16, essentially this is hex, so 10 is 16, so that's my 16 offset, and it contains 71, 72, 73, and 74. You can do the same things using the store instructions, so you can let's make a pointer here and store values into our destination. So I'm just going to do this. We're going to make our R0 pointing to our destination now. And then we can move some of the stuff into that address. So let's store str, whatever is in, let's say, R1 to that address. And then we're going to store R2 into R0, offset it by 4. You can do the same, you can do the rest of the instructions as well, and you can see for yourself that it works just like the load instructions. Okay, so let's debug this. We'll run it until it reaches this instruction. Now R0 will be changed. So if I move 1, R0 is pointing to 1A, and in memory, if I do 1A here, and if I start storing, oh, sorry, 1A. Okay. So if I start storing values into that location, I will see that this memory address will be changed. So, okay. Oh, actually, the address is not word aligned. It's not going to work. So the program actually exited. So let me fix this real quick. When we start storing the alphabet, essentially the last character stopped or ended on an address that is right here. So this would be, if this one right here is 1A, the 00 is 1A, this would be 19, and that's not word aligned. So let me go here and just put in a line. And then that should fix it. Okay, let's see. So we're going to run the program down to this instruction. And then we're going to step through it. So I'm going to go to that memory location. And let's see. So actually, yeah. So R0 now is pointing to 1C. 1C is starting here, which is a word aligned. So now I should be able to store. Here we go. So now I stored my values from R1 into that memory location, and then I can store the next one with an offset of 4. So what comes after this location, this address, it's this base address, which hosts the value of 61 plus 4. So this is plus 1, plus 2, plus 3, and then plus 4 will be starting right here, wherever this 65 is stored. So this will be address 20, this 21, 22, 23, and so on. So you can do the same thing with store instructions as well. So you can do immediate offset, register offset, register scaled offset. Now the question is, well, do I really need to keep track of how much should I advance the pointer by hand? And the answer is no. This is maybe not too practical if you have to iterate through, let's say, a loop, or the program is translated into some sort of loop and it has to iterate over and over. So is there a way to automate this? And the answer is yes. We can update the value of the pointer automatically. I'll show you this in the next video.